Lesson 2G, the transition metals, also known as the multivalent metals. These are metal ions with more than one charge. Looking at the periodic table, we can see that the ionic charges of the elements to the far left and the far right are the same for each column. For example, the alkali metals all form ions that are charged +1, while the alkaline metals all become ions with a charge of +2, and the halogens to the right all become -1 ions. However, if you look in the middle section of the periodic table, we see that some of the metals form ions with different charges. For example, copper, iron, lead, manganese, mercury, and tin. Having multiple charges can cause some issues. A good example of this is iron oxide. Iron has a charge of +2, while oxygen has an ion charge of -2. Crisscrossing, we get Fe2O2. When we reduce, we end up with FeO. Iron also has a second charge of 3+. In this case, when we crisscross with the oxygen ion, oxide, we get Fe2O3. Each of these two ionic compounds are quite different from one another. This is obvious from just looking at the two. FeO is a black substance, while Fe2O3 is a rusty orange color. To differentiate the two, we use Roman numerals to identify which metal ion you're using. So the 2+ iron ion makes iron 2 oxide. The +3 iron makes iron 3 oxide. Please remember, the Roman numeral tells you the metal's ionic charge. Let's look at some examples. Lead 4 iodide uses lead +4 ion and iodide -1. When we crisscross, we get PbI4. Chromium 3 nitride uses chromium 3 ion and nitride 3- ion. Crisscross and reduce to get CrN. Writing formulas from their names is pretty straightforward, thanks to the Roman numerals. Before we look at writing the names from the formulas of these transition metal compounds, let's look at the periodic table one more time. Here we see that there isn't a single nonmetal that has more than one ionic charge. Phosphorus, for example, can only be -3 ion, while oxygen only ever becomes a -2 ion. We'll be using 4 steps to do this task of naming multivalent ionic compounds. First, write the formula. 2. Reverse the crisscross step to come up with the ion's charges. Step 3. Check to confirm that the nonmetal's charge is correct. If it is different, then it has been reduced. You'll need to scale up both the nonmetal and the metal charges if needed. Finally, step 4. Write the compound name using the Roman numerals to identify the metal's charge. You only need to do this if the metal is multivalent. Let's look at some examples. MgCl2. Magnesium is not multivalent, so it's simply magnesium chloride. Next we have Cu3N2. Reverse the crisscross and get Cu +2 ion, and nitride -3 ion. Focusing on nitrogen, the nonmetal ion, we see that it does have the correct ion charge. So that tells us the metal ion charge of +2 is also correct. The name of this compound is copper 2 nitride. Finally, PbS. Reverse the crisscross and we see that Pb +1 and S -1. Sulfur, however, should be -2. That means the subscript must have been reduced, so we need to scale it up back to -2, which is sulfur's proper charge. Lead in turn must be scaled up as well, and is not +1 but +2. PbS is lead 2 sulfide.